Okay, so imagine this for a second.
Mm.
A game-changing technology that just like bursts onto the scene.
Yeah.
And it's not just competing, head to head with the giants.
Right.
It's fundamentally rewriting the rules, the whole game.
Okay.
Now, what if I told you that this tech, backed by one of the world's biggest companies, right, was also largely open, free for anyone to use, build on, tweak?
Yeah, that sounds pretty revolutionary.
Exactly. Sounds like a massive shift, doesn't it? Especially in AI. So today, we're not just scratching the surface. We're diving deep into the, well, fascinating and sometimes pretty contentious world of Meta's Llama AI models.
Right.
And this isn't just another large language model, to add to the list. It feels like more than that.
Oh, absolutely. It's really a strategic phenomenon.
Yeah.
It's dramatically reshaped the whole AI landscape, set new precedents, sparked a lot of debate. It's big. And our mission, really, in this deep dive is to unpack Llama's, well, its dual identity. It's kind of got two sides. On one hand, you've got this sophisticated technical artifact. I mean, it's an engineering marvel, evolving incredibly fast, from just language models to these natively multimodal systems. Super complex. But on the other hand, it's also a really potent strategic tool, something Meta deployed very deliberately to achieve, broader goals.
Right. Strategy.
Exactly. So we'll explore the architectural breakthroughs, we'll trace its journey through the generations.
Like a family tree.
Sort of, yeah.
Yeah.
We'll look at the ecosystem it's created, which is huge. We'll definitely get into the heated debate around openness.
Oh, yeah, the quotes around open.
Definitely any quotes there. We'll analyze its performance, how good it actually is, and then think about the implications. What does this all mean for the future of AI?
Okay.
So by the end, you should walk away understanding not just what Llama is, but really why it matters and how it's, well, changing everything.
That's the plan. And we've really meticulously gone through a whole stack of research here.
We have.
Everything from Meta's own technical papers and announcements to independent academic studies, market analyses, critical commentaries, the whole 9 yards.
It's a lot.
It is. But we've distilled it all down, pulled out the most important nuggets, the key insights, basically giving you the shortcut to being genuinely well-informed on Llama and its impact.
Hopefully saving you some reading time.
Exactly. So let's get into it. Okay, so let's unpack this. Llama stands for Large Language Model Meta AI. But it's not just one single thing, is it?
No, not at all. It's really a whole family of models.
Yeah.
Meta AI started rolling these out back in February 2023. And it was quite a deliberate move, it seems.
And they haven't stood still. It started with LLMs, language models.
All right, foundational language models.
But now the latest versions are LMMs, large multimodal models.
Exactly. They can handle more than just text and now images, too, natively. It's not just a single product. It's all like this evolving lineage getting more sophisticated all the time. And what's really fascinating, I think, and what our sources keep highlighting, is Llama's core technical proposition.
Okay, what's that?
It's engineered to deliver really state-of-the-art performance, but, and this is the key part, in smaller, more accessible parameter sizes.
So efficiency is key.
Hugely key. It's not just about making it powerful. It's about making it efficient. And that's not just, a technical detail. It feels very strategic.
How so?
Well, it aims to lower the resource barrier, right, for AI research, for development. It allows a much broader group, academics, startups, even individual developers, to work with seriously powerful AI without needing, like, a Google-sized budget for computing power.
Right. You don't need a massive data center in your garage.
Exactly. It's like putting the keys to a Formula One car within reach of more drivers, not just the factory teams.
But here's where it gets really interesting, I think.
Yeah.
The thing that truly makes Llama stand out in the market,
Go on.
it's not just the performance or even the efficiency, though those are obviously important. It's the distribution model.
The open aspect again.
Exactly. Before Llama really hit the scene, the whole generative AI world was kind of consolidating around these proprietary closed systems, API-gated models.
Like OpenAI's GPT, Anthropic's Claude.
Right. You paid to get access, use them under their rules, like exclusive clubs. But Meta did something different. They made Llama's weights the core of the model and the inference code available.
Initially for research, then broader.
Exactly. First for research, but then, crucially, for later versions, they allowed commercial use too. And this open approach, well, our sources say it basically ignited a global ecosystem of innovation.
It was a catalyst, definitely.
It feels like it transformed things from these walled gardens into this huge collaborative space for developers everywhere. A fundamental shift.
And if you connect that to the bigger picture, you see just how disruptive it was.
Right.
Llama didn't enter like a quiet, empty market.
Yeah.
It jumped right into this landscape where power was rapidly concentrating.
With OpenAI, Google.
Exactly. Their models, GPT series, PaLM, Claude Access, was almost always through paid APIs.
High barriers to entry.
Very high.
Yeah.
And it stifled independent research, concentrated immense power in just a few hands.
Yeah.
It made it really hard for the broader community to inspect the models, customize them, truly innovate on the core architecture.
It felt like a bottleneck.
It really was.
So, okay, what does this mean for Meta's grand plan? They obviously had the resources, the talent to just build another closed competitor.
Easily.
But they didn't. They went open. And our sources consistently describe this as a calculated strategic disruption.
That sounds about right.
It feels like it fundamentally shifted the whole battlefield. It moved the competition away from just who can build the best proprietary model
Right.
towards a struggle for what? Ecosystem dominance?
I think that's a good way to put it, yeah. Instead of just being another player, they aim to become the foundational layer, the bedrock everyone else builds on.
So it's not just about the tech itself, it's about market leverage.
Absolutely. It's a power play, in a way, exactly. By making this powerful foundational model widely accessible, Meta effectively tried to commoditize that core AI technology.
Make the basic model less of a unique selling point.
Precisely. The value then shifts, right, it shifts away from just providing the raw model itself towards the platforms, the tools, the specialized applications that get built on top of Llama.
Ah, so Meta benefits from everything built using Llama.
Exactly. And that's where Meta can leverage its huge advantages.
Mm-hmm.
Its massive user base, its existing developer relationships, its enormous infrastructure. They build this competitive moat that's really hard for others to cross.
It's like they're not just selling you the engine, they're building the whole road network and encouraging everyone to drive on it.
That's a great analogy.
Yeah.
They become the indispensable infrastructure provider.
So it's really clear from all the material we've looked at, you can't just see Llama as, a cool piece of tech in isolation.
No, you have to see both sides.
You have to see it through this dual lens. It's a sophisticated technical artifact, yes, an engineering achievement.
Definitely.
And it's also this potent strategic tool that Meta is wielding very deliberately.
Right. The architecture, the licensing, the ecosystem, the future plans, it's all interconnected with this dual nature.
It's that interplay that makes the Llama story so compelling, I think.
Agreed. Marvelous. Okay, so let's get into the nuts and bolts a bit. At its core, fundamentally, Llama is built on the transformer architecture.
Which is pretty much the standard now for advanced NLP, right?
It is, yeah.
Yeah.
Specifically, Llama uses an autoregressive, decoder-only transformer structure.
Like GPT models from OpenAI.
Very similar in that basic structure, yes. Think of it like a storyteller that's only focused on writing the next word or the next phrase based on everything it's written so far.
It's always looking back to predict forward.
Exactly. It's not analyzing a complete story written by someone else. It's purely optimized for generating the next piece of its own coherent output, predicting the next most likely token.
Making it great for generative tasks, like writing text.
Precisely. It's a very sophisticated pattern matcher and sequence completer, designed for generation.
That makes sense. And one of the first things that really jumped out at me from the papers was how Meta's engineers didn't just use the standard transformer playbook. They tweaked things, right? Specifically for efficiency, even from Llama 1.
They did. Lots of clever optimizations.
Like, instead of standard layer normalization, they used RMS norm. Root mean square layer normalization.
Right. RMS norm. And it's a pre-normalization technique.
What does that mean practically?
It means normalization is applied to the input of each layer rather than the output. So instead of correcting the model's balance after it's already started processing data in a layer.
Like trying to steady a wobbly boat midstream?
Kinda, yeah. RMS norm ensures the input is stable and scaled correctly before it even goes into the layer's main computation.
So it helps things run smoother.
Much smoother, helps with training stability, makes it converge faster, and actually reduces the computational overhead quite a bit in a proactive stability measure. And this raises the question, why these specific choices? They weren't random.
Every decision has a reason.
Exactly. Another key tweak is in the feed-forward network inside the transformer blocks. Llama uses the switch-ELU activation function.
Instead of the more common ReLU.
Right. Think of an activation function as deciding how much signal a neuron passes on. ReLU is like a simple on-off switch, or rather, off-pass-through. Switch-ELU is a bit more sophisticated.
How so?
It uses gating mechanisms, allowing for more nuanced decisions about information flow. It's been shown to improve performance and also contributes to better training dynamics compared to plain ReLU in many cases. It just gives the model a bit more expressive power.
So again, optimizing performance and stability.
Precisely. Fine-tuning the core components for better learning.
And then there are ropes, rotary positional embeddings. That sounds complicated.
The name is a bit much, maybe. But the concept is important. Transformers need to know the order of words, right? Position matters.
Context is key.
Absolutely. Older models might use absolute positional embeddings, like giving each word a fixed number based on its position.
Okay.
RoPE is different. It applies the rotation to the word's vector representation, and the amount of rotation depends on its position.
Rotation, like spinning it.
Mathematically, yes. Think about relative position. Instead of knowing word #5 is at position 5, RoPE helps the model understand how word #5 relates to word #3 and word #7, its neighbors.
So it's better at understanding relationships between words, especially further apart.
Exactly. It's particularly good for capturing relative positional information, which is crucial for understanding long sentences or documents where the relationship between words matters more than their absolute spot in the sequence. Helps with long-range dependencies. Now, a really significant innovation, this came with Llama 2, Grouped Query Attention, or GQA.
Okay, GQA, why was that a big deal?
To get it, you need to quickly understand standard multi-head attention. The attention mechanism is how the model decides which words are most important when generating the next word.
Right. Paying attention to relevant context.
Precisely. Multi-head attention does this multiple times in parallel, each head looking for different types of relationships. But
There's always a but.
yeah, each of these heads needs its own set of parameters, keys, and values, which have to be stored in memory, especially during inference when you're actually using the model. And that uses up a lot of memory.
So lots of heads means lots of memory needed.
A significant amount, yes. It can be a bottleneck for speed and deployment.
So GQA is the solution. How does it work?
It's a clever compromise.
Yeah.
Instead of every single query head having its own unique key and value head, GQA groups multiple query heads together so they share a single key and value head.
Okay, so multiple askers share the same reference library, essentially.
That's a perfect analogy. Exactly. This drastically reduces the memory footprint and the computational load during inference.
So faster speeds, less memory, without losing the benefits of multiple perspectives.
Largely, yes. It allows Llama 2 and later models to perform much more efficiently, getting closer to the speed of smaller models, but retaining the power and quality of the larger architecture. It directly supports that core Llama goal, powerful and efficient. And then the most, I'd say, profound architectural shift, though, that really changes the scaling game, came with Llama 4.
Which was?
The adoption of a mixture of experts, or MOE architecture.
MOE. Heard a lot about that. What's the core idea?
It allows you to dramatically increase the total number of parameters in a model, but keep the computational cost of actually running it, the inference cost, relatively low.
How does that work? Seems counterintuitive.
Okay, take the Llama 4 Maverick model. It has a massive 400 billion total parameters. Huge number.
Wow.
But for any single piece of input, like predicting the next word, it only activates and uses about 17 billion of those parameters.
Only 17 billion.
The model is divided into many different experts, each specializing in different types of knowledge or tasks. A routing mechanism decides which few experts are most relevant for the current input and only activates those.
So it's like having a huge library of specialists, but you only call the specific ones you need for each question.
Exactly. You have access to vast knowledge, but you only pay the computational cost for the small fraction you actually use at any given moment.
And that's called sparse activation.
That's the term, yes. Sparse activation. It's incredibly clever.
So the model can hold a huge amount of diverse knowledge.
Vast amounts. Different experts for coding, for history, for creative writing, whatever.
But running it feels more like running a much smaller, dense model.
Pretty much, yeah.
Yeah.
In terms of computational cost for inference, this lets Llama 4 achieve performance that rivals models with over 1 trillion dense parameters. But it's far, far more efficient to actually deploy and run.
It's like an efficient brain, only the relevant parts light up.
That's a good way to think about it.
Yeah.
And what's so fascinating, looking back across this whole journey, RMS norm, SWGLU, ROPE, GQA, MODI,
Yeah.
there's this unwavering, consistent focus on inference efficiency. It's clearly not an accident.
It feels like a core design principle.
Absolutely.
Yeah.
And it's not just about making the tech cool in a lab. It's a strategic engineering choice. And it's directly tied, intrinsically linked to Meta's open distribution strategy.
Oh, so?
Well, think about it. If you're releasing a model for the whole world to download and run,
People need to actually be able to run it.
exactly, on their own hardware with varying resources, it has to be efficient. That's very different from a proprietary model where the company controls the hyper-optimized, super expensive infrastructure it runs on.
Right, they can just throw compute at it internally.
Precisely. So this causal link,
Yeah.
the open strategy demanding efficiency and the engineering delivering it, is fundamental to what Llama is. The openness drove the engineering priorities.
Okay, let's trace this family tree then. It all kicks off in February 2023 with Llama 1.
Right. The original release, a collection of foundational language models.
Ranging in size.
Yeah, from 7 billion parameters, relatively small, up to 65 billion. Still quite significant.
And the focus then was mostly research.
Primarily, yes. The license was non-commercial, targeted at academics, research labs,
Yeah.
people who got approved. It was dipping a toe in the water, really.
Oh.
And a really key aspect of Llama 1, tied to that initial open idea, was the training data.
Okay, what about it?
It was trained on 1.4 trillion tokens, which is a lot. But crucially, it was entirely from publicly available sources.
Proprietary data.
None reported. It was a deliberate choice, they said, for transparency, reproducibility.
So what kind of public data?
Things like common crawl web scrapes, public code from GitHub, Wikipedia across many languages, public domain books via Project Gutenberg, scientific papers from Arcsforth, stuff anyone could, in theory, access.
So trying to build trust through transparency from the start.
That seemed to be the message, yeah.
And the results from Llama 1, were they any good?
They were actually quite stunning, especially considering that efficiency focus.
Oh, yeah.
Yeah, the sources highlighted that the ALMA13B model, only 13 billion parameters,
Uh-huh.
it actually outperformed GPT-3 from OpenAI on most standard benchmarks. And GPT-3 had 175 billion parameters.
Wow, okay. Punching way above its weight.
Absolutely. And the bigger Llama A65B model, it was competitive with things like Google's PaLM, which was enormous, 540 billion parameters.
So it wasn't just about making models bigger and bigger.
Exactly. It was powerful proof that you could get top-tier performance by training smaller, well-designed models on massive amounts of high-quality data. It strongly validated those chinchilla scaling laws.
Which basically say data quality and quantity matter more than just parameter count, up to a point.
Pretty much, yeah. Spend your compute budget wisely on data. Llama 1 really showed that efficiency could rival brute force size. Then, just 5 months later, things moved fast. July 2023, Llama 2 arrives.
Okay, round 2. What changed?
This was a major expansion, strategically. Big partnership with Microsoft announced.
Making it easily available on cloud platforms.
Exactly. Azure, AWS, much easier access. And critically, a new license.
The commercial one.
Yes. This was the big shift. It allowed commercial use, though with some important caveats we'll get into. But this is when Llama really stepped out of the lab and became a direct competitor in the commercial AI space.
And technically, did they upgrade it?
Oh yeah, big time. Training data jumped to 2 trillion tokens, 40% more than Llama 1, and they emphasized more robust data cleaning and filtering.
Quality control on the input.
Right. Architecturally, the context lengths doubled to 4096 tokens.
So it could handle longer conversations, longer documents.
And it's longer, yeah. Very important for practical use. And as we talked about, this is where GQA grouped query attention was introduced for better inference efficiency.
So more data, longer memory, more efficient, solid upgrades.
But the real standout innovation for Llama 2, the thing that really made waves, was Llama 2 Chat.
The conversational versions.
Exactly. These weren't just the base models. They were specifically optimized for dialogue. And this involved a really extensive post-training alignment process.
Alignment, making it behave more helpfully and safely.
Precisely. It used a couple of key techniques. First, supervised fine-tuning, or SFT.
Training on good examples.
Yeah, using high-quality, human-written examples of good conversations. Then, crucially, reinforcement learning from human feedback, RLHF.
RLHF. That's where humans rank different responses.
Exactly. Humans would compare different model outputs, say which one was better, more helpful, less harmful, etc. This preference data trains a separate reward model.
And the reward model then trains the main chat model.
You got it. It guides the Llama 2 chat models to better align with what humans actually want and expect. This whole process made Llama 2 a direct, open-source challenger to things like ChatGPT.
Okay, so Llama 1, then Llama 2 with chat. What came next? August 2023, Code Llama.
Right on schedule. Building directly on Llama 2's foundation, Code Llama was, as the name suggests, specialized for coding.
How did they specialize it?
It took the Llama 2 models and did further training, specifically on a massive data set of code. An extra 500 billion tokens, just code and code-related text.
So really immersing it in the world of software development.
Exactly. Deep specialization for that domain.
Yeah.
And this led to several versions tailored for developers.
Okay.
A base foundation code model, a version specifically optimized for Python, which is obviously huge,
Yeah.
and an instruct version, which was designed to follow natural language instructions about coding tasks, like write a function that does X.
Very useful. And these were powerful.
Up to 70 billion parameters, and they achieve state-of-the-art results on many coding benchmarks. Code completion, finding bugs, writing tests, generating documentation.
And you mentioned earlier, tools built on this actually boosted productivity.
Yeah. Sources cite reports of tools like CodeGPT, built using Code Llama, boosting developer productivity by as much as 30%. That's a tangible impact in the real world.
Okay, zooming ahead now.
Yeah.
April 2024. Llama 3. Sounds like another big step.
Monumental, really. The scale just keeps increasing. The pre-training data set expanded sevenfold.
7 times.
Yeah, over 15 trillion tokens, with an even more intense focus on data quality, sophisticated filtering, deduplication,
Cleaning up that massive data set.
essential at that scale.
Right.
And critically, Llama 3 became much more multilingual. Over 5% of the training data was high-quality, non-English text, covering more than 30 languages.
So truly becoming a global model.
Much more so, yes. Architecturally, Llama 3 also saw upgrades. The vocabulary size quadrupled to 128,000 tokens.
Why is a bigger vocabulary good?
It allows the model to encode text more efficiently. It can represent more words, symbols, and concepts with single tokens, which generally improves performance and efficiency.
Got it. And the context window.
For the later Llama 3.1 release, it expanded dramatically to 128,000 tokens.
Wow, 128K. That's huge. That's like a whole book.
Easily, maybe several. It means the model can process and remember vastly more information simultaneously. Opens up amazing possibilities for analyzing large documents, long conversations, huge code bases.
And Llama 3 came in different sizes again.
Initially, yes. 8 billion and 70 billion parameter versions covering a range of needs. But then Llama 3.1 introduced a new flagship, a 405 billion parameter model.
405B. So pushing into that truly massive scale, even with the open approach.
Absolutely.
But
Directly competing at the frontier. And the alignment process shifted too.
From RLHF.
Yeah, they moved primarily to direct preference optimization, or DPO. This is another method for learning from human preferences, but it's often considered more stable and computationally efficient than RLHF, just refining how they teach the model good behavior. And that brings us pretty much up to date. April 2025, Llama 4.
A new era, you called it.
It really feels like it. This generation introduced native multimodality, handling text and images seamlessly from the start, and it fully embraced that mixture of experts, MOE architecture we discussed.
For efficiency at scale.
Exactly. The initial releases were Scout, 109 billion total parameters, but only 17B active, and Maverick, 400 billion total, again, just 17B active.
Showing that MOE efficiency even in the really big models.
Precisely. And they even announced an even bigger one in training, Behemoth, aiming for 2 trillion total parameters. The ambition is just staggering.
And the capabilities of Llama 4. What's new besides MOE and multimodality?
Several key things highlighted in the sources. Native multimodality, as mentioned, using early fusion processing text and vision together right from the input layer.
So it truly sees and reads at the same time.
That's the idea, yeah. Deep integration. Then, extreme long context. The Scout model supports up to 10 million tokens.
10 million. That's insane. What can you even do with that?
Analyze entire code repositories, massive archives of documents, potentially lifelong conversations. It's industry-leading. Also, advanced image grounding.
Meaning?
It can connect text descriptions to specific regions within an image, like the red ball on the left, very precise visual understanding, and enhanced multilingualism across 12 core languages.
No.
But Llama 4 also marked a shift in the training data, which caused some comment.
Oh, how so?
For the first time, the training data explicitly included licensed data and also meta-proprietary data.
Like Facebook and Instagram posts.
Publicly shared ones, yes.
Yeah.
But still, a move away from that publicly available data-only principle of Llama 1, 2, and 3.
Why the change, do you think?
Pushing to the absolute frontier might require data beyond what's freely available online. It suggests maybe the limitations of purely public data are being felt as they aim for top-tier performance against closed models trained on everything. It's a complex trade-off.
You can really see the whole story laid out when you look at the comparison tables in the research.
Yeah, those tables are great.
Parameters skyrocketing, training data exploding, context windows getting massive, key innovations like GQA and MoE slotting in. It's just this picture of relentless progress, generation after generation.
An incredibly rapid pace of evolution in just a couple of years. Truly remarkable.
Oh, wow. So all this technology, this rapid development, it's led to this incredibly vibrant ecosystem around Llama.
Right. It's not just sitting in a lab.
Not at all. And its adoption isn't just because it tops every single benchmark chart, although it does very well. It's more about the overall package. What do you mean?
It's that compelling mix. Really high performance, yes, but combined with significantly lower costs compared to proprietary APIs, and crucially, that element of control and data sovereignty.
Being able to run it yourself on your own data.
Exactly. For so many companies, the ability to fine-tune a powerful model like Llama on their own sensitive proprietary data inside their own secure systems, that's a massive advantage. It often outweighs chasing that last percentage point of performance from a closed model where you have to send your data out. Privacy and control are huge drivers.
That makes a lot of sense. And we're seeing businesses jump on this.
Across the board, enterprises are adopting Llama for all sorts of workflow automation.
Like customer service.
Definitely. Intelligent chatbots, virtual assistants powered by Llama, they can provide 247 personalized support, cut wait times, handle huge volumes of queries way more efficiently. It's about streamlining those interactions, tailoring the support.
Moving beyond basic FAQs to actual problem solving.
Right, making customer service faster and potentially better. And it extends to content creation too. Marketing teams are using Llama pretty heavily.
Generating blog posts, social media stuff.
Yeah, and product descriptions, personalized email campaigns, generating high-quality content at a scale that would be impossible manually.
And can it tailor the content?
That's the key. The models can analyze customer data, segment audiences, and then craft copy designed to resonate with those specific groups, moving from broadcast messaging to really targeted communication.
What about data analysis? That seems like a natural fit.
Huge area. Law models are being used to process and summarize enormous data sets, pull out key insights much faster than humans could, generate concise reports.
Accelerating decision-making.
Significantly.
Right.
And also automating those repetitive data-heavy tasks. Think processing invoices, summarizing long meeting transcripts, drafting standard reports. It frees up people for more strategic work.
The stuff that needs human judgment.
Exactly. Let the AI handle the grunt work. And we already touched on Code Llama, but its impact in software development is worth reiterating.
The coding assistant.
Right. Generating code snippets, debugging, writing test cases, documentation. Developers are using it constantly.
And the productivity gains are real.
The sources suggest they are. Studies and user reports point towards tools built on Llama boosting developer productivity by up to 30%. That's a massive gain in a high-value field.
What about specific industries? Are there standout examples?
Oh, absolutely.
Yeah.
Healthcare is a fascinating one. We saw researchers develop Metatron from Llama 2.
For clinical information?
Yeah, providing evidence-based info. Think about supporting healthcare workers in remote or underserved areas. Huge potential.
That's powerful.
And in Brazil, NoHarm.ai uses Llama 2 to help draft patient discharge summaries in Portuguese. Improves hospital efficiency, reduces errors. Then there's OpenBioLM based on Llama 3, setting new benchmarks for biomedical research. Real impact. Finance and legal, too. Conversa uses Llama for call center analytics. They reported a 10x reduction in operational costs compared to using OpenAI's models.
10 times cheaper.
With better accuracy, they claimed. That really highlights the cost efficiency. And in legal tech, a startup called Blinder uses Llama to anonymize sensitive data and help draft legal documents. Faster work, better confidentiality.
Education as well.
Definitely. MathPresso in South Korea built MathGPT using Llama 2, an AI math tutor.
Specializing the model for learning.
Right. And maybe even more inspiring, UPO Labs in Kenya developed SomoGPT. It's a Llama-powered tutor for high school subjects, accessible via chat, making advanced educational tools available much more widely, democratizing access. But maybe the biggest impact, the most profound one, isn't just in these specific applications, it's on the global open-source AI community itself.
The developer community.
Yeah. The growth there has been explosive. Sources mentioned over 30 million downloads of Llama-based models by late 2023.
And that grew.
Exploded. Over 1 billion downloads reported by March 2025.
A billion.
It's staggering. It shows this community isn't just using Llama. It's become this massive decentralized engine of innovation, a real force in the industry now.
So what does that actually look like? What is this community doing?
Thousands of derivative models have sprung up. You see them on platforms like Hugging Face.
Variations on Llama.
Exactly. Models fine-tuned for super specific tasks, particular languages, different writing styles, even models focused on improved safety or ethics. It's crowdsourced optimization on a massive scale.
And it leads to real improvements.
Absolutely. Sources show community fine-tuning has led to performance gains as high as 46% on certain benchmarks. They extend capabilities, like creating tiny versions that can run on phones.
Quantized models.
Right, or pushing context windows even further than the official releases. It's this vibrant, decentralized, collaborative innovation pipeline. And it's a direct result of Meta's open strategy. It unleashed this energy. Now, publicly, Meta always frames this open approach in very principled terms.
Democratizing AI, safety through openness, that kind of thing.
Exactly. Leaders like Zuckerberg, Jan LeCun, they consistently argue that building AI out in the open allows for broader scrutiny, more eyes on the code, on the model.
The idea being that a diverse community can spot biases, find risks better than a closed team.
That's the core argument, that collective oversight leads to safer, more robust, less biased technology in the long run. It's presented as a sort of collective responsibility model for safety.
And Zuckerberg has been pretty explicit about the endgame, hasn't he?
He has, stating his belief that open source AI will become the industry standard. He talks about it creating the greatest economic opportunity and security for everyone.
And LeCun draws parallels to Linux.
Frequently. How Linux started as this open project and eventually became the foundation for, well, pretty much the entire internet infrastructure, cloud computing.
So positioning Meta as the champion of this open, collaborative AI future.
That's certainly the narrative. It contrasts sharply, deliberately, with the closed proprietary models of their rivals, paints a picture of Meta enabling this shared technological future. But beneath that idealism, let's be honest, the sources reveal a very shrewd competitive strategy.
It's not just about idealism.
Probably not entirely, no. By releasing these incredibly powerful, near state-of-the-art models essentially for free, Meta is very effectively aiming to commoditize that foundational LLM layer.
Make the base model itself less valuable as a product.
Precisely. And that directly challenges the business models of competitors like OpenAI, Anthropic, Google, who primarily make money selling API access to their closed models.
Because if developers can get 95% of the performance for maybe 10% of the cost, or even free,
the incentive to pay for expensive APIs shrinks dramatically, doesn't it? It's a classic commoditization play, shifting the economic battlefield.
and it builds those network effects you mentioned earlier.
Hugely powerful network effects. You get this massive ecosystem developing tools, skills, applications around Llama's architecture. It becomes sticky. People invest time and resources in
It
it.
makes it harder to switch away.
Exactly. Plus, it's a fantastic recruiting tool. Top AI talent often wants to work on influential open projects that have real-world impact.
Makes sense.
And crucially, it effectively outsources a massive chunk of R&D. The global community finds bugs, develops new use cases, stress tests the models, identifies vulnerabilities.
All providing invaluable feedback to Meta.
For free. From a strategic perspective, it's brilliant. Lots of upsides for Meta. Okay, but now we get to get into the controversy. Despite Meta constantly calling it open source, is it really?
The $1 million question. Or maybe the $0 question given the license.
Well, the Open Source Initiative, the OSI, they're kind of the official arbiters of what open source means. Right. They've repeatedly said that Llama's license, especially from Llama 2 onwards, doesn't actually meet their established definition.
So not technically open source, according to the OSI.
According to their strict definition, no. And this isn't just splitting hairs. It's about core principles of the open source movement.
So what are the specific problems? What parts of the license violate OSI principles?
Our sources point to a few key restrictions. First, discrimination against groups.
How so?
The Llama 2 license and later ones have this clause that prohibits use by companies with over 700 million monthly active users unless they get a separate deal with Meta.
Which basically targets, Google, maybe TikTok.
Pretty clearly targets major potential competitors, yeah.
Yeah.
And the OSI definition explicitly forbids discriminating against persons or groups. That's a core tenet.
Okay. Yeah.
Second, restriction on fields of endeavor. There's an acceptable use policy that restricts certain activities.
Like you can't use it for illegal stuff. That sounds reasonable.
It goes beyond just illegal activities, though. The OSI argues that any restriction on the field of use violates the principle that open source software must be usable for any purpose. No arbitrary limitations.
Okay. That's a stricter interpretation.
It is. And third, and this one's really unusual, the Llama 4 license introduced geographic restrictions.
Seriously? Like where you can use it?
Yeah, it explicitly excludes individuals in the European Union from its rights grant, which is, again, a clear violation of non-discrimination principles and raised a lot of eyebrows. Now, Meta defends this. They argue that the old OSI definitions, written for traditional software, just don't work for the unique risks of powerful AI models.
They're saying AI needs new rules.
Essentially, yes. That the potential for harm requires different kinds of controls, even in an open context. But critics...
They call it open washing.
That's the term, yeah. Critics argue Meta is using the positive reputation and community goodwill of open source for marketing while keeping significant control through these restrictive licenses.
So it's not truly free as in freedom, just free as in beer.
That's the criticism. Many in the community prefer terms like open weight or publicly available as more accurate descriptions than open source for Llama. It highlights that tension between the marketing and the legal reality.
But, okay, leaving the licensing debate aside for a moment, just the fact that the model weights are out there, publicly available, that creates risks, right?
Absolutely. Unavoidable risks. Once those weights are downloaded, Meta loses direct control over how they're used or modified. The genie is out of the bottle. And the most immediate concern, the one everyone talks about, is malicious use.
Bad actors using Llama for bad things.
Exactly. Generating misinformation at scale, propaganda, really sophisticated phishing emails, hate speech, you name it.
But don't the models have safety guardrails built in?
They do. Meta puts a lot of effort into alignment. But here's the problem with open weights. Those guardrails can potentially be removed or bypassed. Anyone with a technical skill can fine-tune the model to ignore the safety training and generate harmful content.
So the safeguards aren't foolproof once it's out of Meta's hands?
Not if someone is determined to remove them, no. That's the core risk of releasing the weights.
And the transparency. You said it's a double-edged sword.
It really is. Openness allows the good guys researchers, the community, to audit the model, find flaws, check for bias. That's good. But it also potentially makes it easier for the bad guys to find and exploit vulnerabilities.
Like prompt injection, tricking the model.
Prompt injection, yeah. Or maybe discovering ways to poison the training data if someone were to fine-tune it on contaminated data. It just lowers the barrier for understanding the model's weaknesses for both good and bad actors. And this leads to a really important point, this shift in responsibility.
How so?
With a closed proprietary model run via API, the company providing it, OpenAI, Google, whoever handles the infrastructure, the security updates, the content moderation, the safety tuning, the responsibility largely lies with them.
Okay.
But with an open weight model like Llama, that burden shifts almost entirely to you, the person or company deploying it.
So I become responsible for the GPUs, the servers.
Yes. And for mitigating bias in my specific use case, ensuring my application complies with regulations like GDPR or HIPAA, preventing misuse by my users, it's a huge undertaking.
Complex and potentially very expensive.
Exactly. And many smaller organizations or individual developers might not be equipped to handle all of that responsibility effectively. It's a significant, often underestimated consequence of the open model.
Now, here's where Meta's own story gets a bit complicated. Maybe even contradictory.
You mean the recent discussions about Behemoth?
Exactly. Our sources mention talk within Meta's new superintelligence lab, their AGI-focused group, about potentially not open sourcing their next truly massive model, Behemoth.
Right. Keeping the most powerful one closed, proprietary.
Which seems like a major strategic shift, doesn't it, after all this talk about open source being the future?
It would be a significant pivot, yes. And it suggests perhaps a recognition inside Meta that the open strategy, while incredibly successful for building an ecosystem and competing broadly,
might not be the best strategy for winning the race to AGI.
potentially. Maybe they feel that at the absolute cutting edge, the very openness that helped Llama succeed could become a liability. Rivals could learn too quickly, replicate breakthroughs too easily.
So openness for the masses, but secrecy for the superintelligence race.
It reveals this deep, almost paradoxical tension, doesn't it?
Oh.
Meta championing open AI for the broad market, while simultaneously pursuing this high-stakes, secretive arms race for AGI, backed by billions in private investment.
It's a fascinating strategic duality. Open for the ecosystem, closed for the crown jewel.
It seems that way, a complex balancing act.
Okay, so let's talk performance. After all the strategy, the architecture, how good actually is Llama? How does it stack up against the competition?
Right, the bottom line. Well, the benchmark data we've seen is pretty clear. The latest high-end Llama models, Llama 3.1 405B, the Llama 4 series they perform at are very near the absolute state-of-the-art.
Seriously competitive with GPT-4o, Claude 3.5 Sonnet.
Absolutely, they're challenging them directly, and in some specific areas, even surpassing them, according to standard benchmarks. It's not a second-tier player, it's right there at the top. If we look at some specifics from the data.
Yeah, let's get concrete.
Okay, reasoning and general knowledge. On MMLU Pro, which is a tough benchmark, Llama 4 Behemoth, even just in previous, scored 82.2%, very strong. On GPQA Diamond, which is super hard reasoning, Llama 4 Behemoth hit 73.7, that's significantly higher than Maverick at 69.8. And importantly, much higher than GPT-4's reported 53.6% on that specific benchmark setup.
Wow, a big lead in complex reasoning there.
Seems so on that test. Then coding. On Live Code Bench, which uses recent problems, Llama 4 Behemoth 49.4 and Maverick 43.4 show really top-tier coding abilities.
So Code Llama's legacy continues.
Looks like it. Mathematics. Llama 4 Behemoth scored 95.0 on the Math 500 benchmark. That's frontier performance, a big jump for Llama, and multimodality, because Llama 4 is natively multimodal.
It does well on vision language tasks.
Very well. On MMMU, a key multimodal reasoning jest, Behemoth 76.1 and Maverick 73.4 score highly, showing that integrated understanding of text and images.
So looking at that data, it feels like the AI landscape is incredibly competitive right now.
Highly competitive and really nuanced.
No single model is just wiping the floor with everyone else across every single task.
Exactly. Each model seems to have its own particular strengths. GPT-4o might excel in general conversation fluency or user preference for creative tasks, perhaps. But Llama 4 is showing state-of-the-art results in areas like multimodal reasoning, coding, and definitely that extreme long context capability.
So the best model really depends on what you need it for.
Precisely. It's not a simple horse race with one clear winner. It's more like a decathlon, with different champions in different events.
And qualitatively, putting the numbers aside, what are Llama's core strengths?
Well, we keep coming back to it.
Yeah.
Efficiency and accessibility, that seems paramount. Absolutely. High performance relative to size.
Yeah.
That means smaller models like Llama 3.8B can run locally, on consumer hardware even. And Llama 4's MoE gives you huge power with low running costs. It's a massive strength.
Then the customizability.
Huge advantage.
Oh.
Open weights mean you can fine-tune it for your specific niche task. A specialized Llama can often outperform a giant general-purpose model on that specific task. And the latest versions have excellent multilingual and multimodal skills, too. Very versatile.
But it's not perfect, right? Are there weaknesses?
Sure. Our sources suggest that sometimes on the absolute broadest, most complex, sort of kitchen sink reasoning tasks, the very biggest Llama models might occasionally lag slightly behind the very latest giant proprietary models.
Okay.
And also latency. The biggest Llama models, like the 405B, can sometimes be a bit slower to respond compared to smaller models or highly optimized proprietary APIs.
So maybe not ideal for super real-time applications.
Potentially, depending on the specific setup and requirements. There are always trade-offs. But ultimately, when you weigh everything, performance, cost, control, flexibility, Llama's most compelling advantage, its core value proposition, really is that performance-to-cost ratio.
Bang for your buck, essentially.
Unmatched bang for your buck, yeah.
Yeah.
For so many organizations, getting, say, 98% of the capability of a top proprietary model, but at maybe 10% of the cost.
While keeping your data private and controlling the deployment.
That's transformative. It just changes the economics of implementing AI dramatically.
Can we put a number on that cost difference?
Well, one source mentioned an experiment on text summarization.
Okay.
They found that using GPT-4 for the task could be 18 times more expensive than using the largest Llama 2 model to get similar quality results.
18 times.
That's the kind of economic reality we're talking about. And when you combine that massive cost saving with performance that's often state-of-the-art plus the control, It makes Llama a fundamentally different and often far more practical choice for many, many users compared to the closed source options. Hashtag 7. Inherent limitations and technical challenges. Now, it's really important we also talk about the limitations. No AI model is perfect, and Llama is no exception.
Top of the list is usually hallucinations, right?
Absolutely. Like all current LLMs, Llama models can and do hallucinate. They generate text that sounds perfectly fluent, totally plausible, but it's factually wrong, nonsensical, or just completely made up.
And that's not really a bug they can just fix.
Not in the traditional sense, no. It's more like an emergent property of how they work. They're predicting the next likely word based on patterns and data, not based on actual understanding or fact-checking. They're sophisticated mimics, not reasoning entities.
And that's obviously dangerous in some areas.
Hugely dangerous. Medicine, finance, legal advice. Anywhere, factual accuracy is critical. Meta works hard on filtering data and alignment, RLHF, DPO, to reduce this.
But it still happens.
It still happens.
Huh.
And crucially, in the open source context, who's responsible for checking the facts?
The user, the deployer.
Exactly. The responsibility for verifying output, implementing safeguards like retrieval augmented generation, RAG, to pull in real facts that falls squarely on you when you deploy Llama. Another major challenge is bias.
Learning prejudice from the training data.
Precisely. These models are trained on trillions of words from the internet. And the internet, well, it contains a lot of human biases.
Gender, race, cultural stereotypes.
All of that. The models learn these patterns and can replicate them, sometimes even amplify them. Sources mention studies showing LLMs suggesting different careers based on perceived nationality, for example, reflecting societal bias, not reality.
Again, Meta tries to filter and align against this.
They do. Significant effort goes into mitigating harmful or biased outputs. But again, no technique is perfect. Bias creeps in.
And fine-tuning can make it worse.
It can. If you fine-tune Llama on your own dataset, which might have its own biases, you can inadvertently introduce new ones or resurface biases the original training tried to suppress.
So as a deployer, you need to be constantly vigilant.
Absolutely. It requires ongoing, rigorous bias detection, evaluation, and mitigation. It's not a one-time fix. It's a continuous process and a serious ethical responsibility for anyone deploying these models. And this leads to that really tricky dilemma, especially acute for open models. The scalability versus safety problem.
The tension between making models powerful and making them safe.
Exactly. With a closed proprietary model, the company keeps control. They manage the safety guardrails through the API. They implement content filters. They can update things centrally.
A single point of control and accountability.
For better or worse, yes. But with open weight models like Llama, that control is relinquished once the weights are out there.
Because anyone can download them and potentially remove the safety features.
Precisely. Anyone with the technical know-how can fine-tune the model to bypass or completely strip out the safety alignment Meta worked hard to put in.
And as the models get more powerful,
the potential for misuse grows exponentially. The very freedom and flexibility that drives innovation in the open source community also makes these powerful models attractive targets for those who want to generate harmful content without restriction.
So the responsibility shifts again.
Fundamentally, it shifts the burden of responsible AI governance from a single company like Meta to this vast, distributed, often anonymous global community of users. And frankly, that's a huge, complex, and largely unresolved challenge for society as a whole. How do we manage the risks of powerful open technology? There are no easy answers yet. #8, the future trajectory of Llama. So where is all this heading? What's the future for Llama? Well, Meta's ambitions go way beyond just better chatbots.
They're talking about AGI, right? Artificial General Intelligence.
Explicitly, Mark Zuckerberg has stated the company's goal is to build AGI, framing it as personal superintelligence that should be accessible to everyone.
That sounds ambitious.
Hugely ambitious.
Yeah.
And they're backing it with staggering investment. We're talking potentially hundreds of billions of dollars for these massive AI data centers, multi-gigawatt facilities, each like a small city in terms of power and complexity.
This isn't a side project.
Not even close.
Yeah.
This is core strategy.
And they created that superintelligence lab.
Right, a dedicated division, pulling in top AI talent from all over the world, specifically focused on this AGI goal.
So where does Llama fit into that grand vision?
In that context, Llama models look less like the final product and more like foundational steps. They're the public-facing component, yes, but also invaluable test beds.
Learning from how the community uses and breaks Llama.
Exactly. The community's experimentation, their fine-tuning, their discovery of limitations and novel capabilities, All that provides an incredibly rich stream of real-world data and feedback that feeds directly into Meta's frontier research for AGI. Whether those future frontier models stay open or go closed, Llama is paving the way and providing crucial insights. And this suggests the future of AI development probably isn't going to be purely open or purely closed.
More like a mix, a hybrid landscape.
That's what the sources strongly indicate, a kind of stratified future. You'll likely have both thriving open ecosystems and intense competition at the closed frontier.
So on one level, we'll see this vibrant open source world, probably led by Llama.
Very likely. A whole ecosystem of powerful open models forming the foundation for the vast majority of AI applications out there.
Getting smaller, more efficient, running everywhere.
Exactly. On servers, on phones, on edge devices. Specialized for countless tasks. For most businesses, most developers, that combination of high performance, low cost, and control will make open models the default choice. But simultaneously, at the very top end.
The race for AGI continues in secret.
Well, perhaps not total secret, but certainly in a more closed, proprietary way. You'll have a handful of heavily funded players, Meta, OpenAI, Google, Anthropic, maybe others, pushing the absolute boundaries of AI capability.
Building these frontier systems.
Right. These models, which might never be fully released publicly, will drive the most advanced applications and represent the cutting edge of the AGI pursuit. It's a high-stakes race among giants.
And you mentioned collaboration possibly increasing, even among competitors.
Yeah. As building these foundational models becomes even more complex and expensive, sources suggest we might see more collaboration.
On what kind of things?
Maybe on curating massive pre-training data sets, establishing common safety standards, perhaps even sharing some foundational model components. A recognition that some challenges are just too big for any one company to tackle alone.
So a mix of intense competition and necessary cooperation.
It seems like a plausible future, a complex, multi-layered AI world. Hashtag outro. So wrapping this all up, it's really quite remarkable how much Llama has changed the AI landscape in such a short time.
It really is.
It fundamentally shattered that assumption that cutting-edge AI would always be locked away in proprietary labs. It proved that high-performance open-weight models were not just possible, but incredibly powerful.
A strategic gambit that paid off.
Absolutely. It successfully commoditized that foundational layer, forced the whole market to reevaluate, and sparked this global ecosystem of innovation that's now a major force in its own right.
And it's been a story of just relentless innovation, hasn't it? From efficiency tweaks in Llama 1 to native multimodality and crazy long context in Llama 4.
Technically brilliant evolution. But Llama's legacy is also complex. It's tangled up in controversy.
The open source debate, the risks.
Exactly. It's brought these huge, unresolved questions about how we govern powerful open technologies right to the forefront. It shifted the burden of safety and ethics from just the creator to this vast, distributed global community. And we're still figuring out what that means. And as Meta pushes towards superintelligence, that dual-track strategy we talked about, the public open models and the private frontier research, it suggests Llama's role as both tool and strategy is only going to get more complex. It's cemented its place as one of the most consequential projects in AI history. Which leads to a final thought for you, our listener. What do you think will be the long-term impact of this kind of bifurcated approach to AI? This split between open foundations and closed frontiers? Will it ultimately accelerate progress faster for everyone? Or will it deepen the divides and maybe concentrate power in new, unexpected ways?
That is definitely something to mull over. A lot to think about there. We really hope this deep dive into Meta's Llama has given you a clearer, more informed, and maybe more nuanced perspective on this truly game-changing technology and everything surrounding it.
Hope it was useful.
Until next time, keep digging, keep learning, and as always, stay curious.